Hello guys, welcome back to my YouTube channel. So today we are going to solve day 26 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2458. Height of binary tree after subtree removal queries. Okay, so this problem is actually marked hard by LeetCode, and by the end of this video you guys are going to learn a lot of new things which you can use to solve more questions related to trees and all other things, right? So we are going to learn a lot of new things in this problem, and this problem is actually very interesting, I'm going to say. Okay, so let's make this problem a little bit easy. Okay, so now let's read the problem statement first. So you are given the root of a binary tree with n nodes. Okay, and each node is assigned a unique number from 1 to n. You are also given an array queries of size m. Okay, clear? This line is clear. You have to perform m independent queries on the tree, where in the ith query you do the following things. Okay, we have to remove the subtree rooted at the node with the value queries of I. Okay, we have to completely remove the subtree rooted at that node from the tree. Okay, and it is guaranteed that queries of I will not be equal to the value of the root. Okay, so this is given. Okay, clear? Return an array answer of size m. Okay, of size m, where answer of I is the height of the tree after performing the ith query. Okay, so height of the tree. Okay, so this is I think most of you guys aware of this, how to calculate the height of tree, right? So we will see in today's problem as well. Okay, we will just little bit modify the code of this height of tree. Okay, and you will be able to solve this problem easily. Okay, so the queries are independent, so the tree returns to its initial state after each query. Okay, so tree is going to return to its initial state after each query. The height of a tree is the number of edges. Okay, so this is the definition of height of tree. The height of tree is the number of edges in the longest simple path from the root to some node in the tree. Okay, clear? Okay, so now let's read the see how we are getting the output for example number 1. Okay, this is nothing but example number 1. Okay, so this is tree given to us. Okay, so how we calculate the height of a tree? So simple. So we move to the left side, okay, to see the number of nodes in the left. Okay, we calculate the height from the left side, we calculate the height from the right side. Okay, and then after that total height we calculate as max of my left and right. Right, this is simple thing that we do. Okay, so here let's see here for this 2. Okay, if I move to the left side, there is nothing. Okay, there is nothing in the left side, so from here I am returning 0. Okay, so this 0 is showing that there are 0 number of nodes. Okay, here I am talking about the number of nodes right now. There are 0 nodes which are returned. Okay, here 2's right side, there is nothing, null. So from here also I am returning number of nodes as 0. Okay, so from left and right I am returning 0. Okay, and here at this 2, what I am going to write here, total number of nodes that I have at this 2 is nothing but max of my L and R, and in this I'm just going to add 1. Okay, and this is right. So if there is just 2, then we will get this one. Okay, so this is 1. Okay, and now from here I'm going to return this one. Okay, to here. Okay, and in the right of 3 there is nothing. Okay, so from here I'm returning 0. Okay, and from here I'm returning 1. Okay, so add 3, but I have to do, but I will get max of L and R. So max of L and R is 1. Okay, from here I'm returning 1 and here I'm returning 0. So 1. And here 1 plus 1 I will get 2. Okay, so from here I'm going to return 2. Okay, from this side I'm returning 2. Okay, this is nothing but left of 1, right? And now let's see the right of 1. Okay, so here for this 7, here it is going to return 0. For this 7 in the right, it is again going to return 0. So at 7 we have max of L plus R, L comma R plus 1, so 1. So from here I'm returning 1. Okay, so for 5, here is this side, it is going to return 0. So max of L and R, which is 1, and here plus 1, so here 2. Okay, so from here I'm returning 2. Okay, and same way from 6, here 0 from its left and 0 from its right, and at 6 we have max of L R plus 1, so 1. So from here I'm returning 1 here. So for 4, 1 and 2, which is max, 2 is max, so in this 2 I'm going to add 1, 3. Okay, so from here I'm returning 3 here. Okay, so 2 and 3, which is max, 3 is max, so 3, in 3 I'm going to add 1, so I will get 4. Okay, so here I'm getting 4. But here we are talking about but we need the height of a tree, but I am here calculating the number of nodes. Okay, max number of nodes if I want to check from the root, and I'm getting 4. In which direction? So see this white highlighted. Okay, 1 2, okay, in this path, just see this path, 3 and 4. Okay, so in this path I am getting the max number of nodes, right, which is nothing but 4. So I can calculate the number of edges as well using the same thing. So if I subtract 1 from this, I will get 3, and 3 is going to be my number of edges. Now see this pink color. Okay, 1 2 and 3. Okay, so 3 is the height here. Okay, so total number of nodes, and if I subtract 1 from it, I will get the height. Okay, height is nothing but height of tree is the number of edges in the longest simple path. So we know the path in which we are getting the max number of nodes. So definitely in that particular path we have max number of edges as well. Okay, so how we are going to calculate the edges? So max number of nodes in that path and subtract 1 from it, we will get the max height. So this is a simple thing, right? Simple recursion. Okay, simple code for to get the height of tree. Okay, so this is clear. Okay, so now what this question is saying. Okay, so this is clear, right? How we are going to get the height. Okay, so here this is given queries of 4. Okay, so now what does this mean, queries of 4? Okay, so we have to remove the subtree rooted at the node with value. Okay, so at this value. Okay, all the values are unique. So problem is saying that remove this for okay, for subtree, completely remove this part. This is what problem statement is saying. Okay, so now let's remove it. So in the end I will be left with this only, right? 1, and after 1 here 3, and here 2, and in this there is nothing. Okay, I have removed it, let's say. Okay, so now after removing it, so what is the height that I'm getting here? So at this, if you see, total number of nodes in this path is 3, and height is going to be 3 minus 1. Okay, so I will get 2. So 2 is the height, 132. Okay, so here 132 we are left with. So diagram above shows that 3 after removing the subtree rooted at node with value 4, and the height of tree is 2, 132. Okay, so 132, total number of nodes 3 minus 1, so we will get the height. Okay, so this is what we need to return, and the length of output is same as the length of queries. Okay, so this is clear, right? Now what we need to do here. Okay, so from here two things. We need to know about this level. Okay, so let's forget about this. Okay, so let's say if I remove it, I will get this one. Okay, and we will get the height from here like this. Okay, so here 0 and here 1, I'm returning 1 here, and at this level I will get 2, and here at this level I will get 3. 3 minus 1, I will get 2. 2 is nothing but the height. Okay, so one thing is clear, how to get the height. Okay, so this is clear. Now let's move to the example number 2, and now I will show you what I'm going to do in my code to get the output. Okay, this output. Okay, so here this is my example number 2. Okay, so here one second, let me join this. Okay, so here this is nothing but this is nothing but my level 0. Okay, level 0, let's say. And this is nothing but my level 1. This is nothing but my level 2, and this is nothing but my level number 3. Okay, so here I'm just giving the levels. Okay, and can I write the heights as well? So at this I will get height, number of nodes here at this level 1, 1. Okay, and at this level I will store 2. Okay, from here I will get 1. It is going to return 1 here. So 2 1, max is 2, so here I will get 3. And here 1 here, 1 here. Here I will get 2, 3 2, which is max, 3 is max. So here I will get 4. Okay, so this is nothing but height. Okay, I'm writing height only here. 1 second, let me cover it in like this. Okay, so in blue color I'm writing the height, so number of nodes only, and using these I will get the height later on, right? I have to just subtract 1 from it, right? Number of nodes I have written here. Okay, so this is the same thing, right? This is the same thing that I was doing here. Okay, so that's why I directly wrote it here. Okay, so now what you need to do here. Okay, so here we are going to create a few arrays. Okay, so here let's create one array name as level. Okay, and in this level how many number of nodes we have? Until 9, right? Total 9, right? So here let's create this level. Okay, so here I'm just going to store the levels. Okay, so let's name it as level. Okay, so here uh, here what I'm going to do. Okay, so here I'm above, I'm going to write the nodes. Okay, here I'm going to write the node, which is nothing but indexes that I have. Okay, so here nodes, or these nodes. Okay, we have nodes from 1 to 9, right? In this example, 1 to 9 is the max, right? 9 is the max. Okay, 1 to 9. Okay, so here I'm starting from 0. So 0 we don't have any node. Okay, so I'm just writing x here. Okay, so then we have a 1, we have 2. Okay, we have 3 here, let's say 4 here, 5 here, 6 here I'm going to write, let's say 7 here I will write, 8 here I will write, and until 9 we have, right? And 1 is at which level? 1 is at level 2. Okay, level 2 we have 1. So here I'm going to write 2. Okay, level this node 1 is at level 2, and node 2 is also at level 2, node 3 is also at level 2, node 4 is at level 3, node 5 is at level 0. Okay, and node 6 is at level here 6 6 level 3, right? And this 7 is at 1, sorry, 2. Okay, 7 is at level 2. Okay, so let me just control it. Okay, this is at level 2. Level this node 8 is at level 1, and node 9 is at level 1. Okay, I will show you how I'm going to fill this array. Okay, I will show you a little bit later, but see, I have written the levels here. Okay, so one node is at level 2, two node is at level 2. Okay, so this is one thing that we have to do. And here let's write the heights as well. Okay, height of all the nodes that we have. So here same thing. Okay, so here I'm just going to write the heights. Okay, and here let me write height. Okay, height. So we don't have this 0 node, so here I'm just going to write x, cross it. Okay, 1, let me fill it again, 2, 3, 4, 5, 6, 7, 8, and 9 we have. Okay, so now for 1, what is the height? Okay, uh, what is the height, or you can say in the notes that we have height, I will subtract -1 later on. Okay, so here for 1 I'm storing 1 here now, so here I'm just going to fill 1. Okay, all right. For 2 I am filling 2 here, so I'm just going to add 2. For 3 I'm adding 1 here, so let's add 1. For 4 I am adding 1. For 5 I'm adding 4. Okay, and for 6 I am feeling 1. Okay, for 7 I am feeling 1. For 8 I am feeling 3, and for 9 I am feeling 2. Okay, so this is what I get. Okay, so I have filled the levels and height. Okay, but why I'm doing that? Okay, why I'm doing that? Okay, so here first, okay, let's see. If I want to remove this subtree 3, okay, I want to remove it. Okay, I removed it. Let's say. Okay, so now what is the max height? Max height will be this 3 only, right? That is why we are getting 3 here. Okay, so here can I do one thing? Okay, so here I will check the level of this node 3. Okay, this 3 node I am removing, so I will check the level of this. So level of this node 3 is 2. Okay, and now after that I will check in this same level, what is the max height value. What is the max height value in this same level? Okay, so at this level what we have node 2, 1 and 7. Okay, we have node 2, 1 and 7 at the same level. So out of this 2, 1, 7, you see what is the max height. So at node 1 height is 1, at node 2 height is 2, and at node 7 height is 1. Okay, so 1, 7 and 2, what is the max we are getting? We are getting max at this node 2, right? At this node 2 we are getting the max height, which is nothing but 2. Okay, so in this level 2, okay, this is nothing but level. At level 2 I removed this. At level 2 I removed 3. Okay, and then after that at this particular level I am getting the max height. Then the max height is nothing but 2. Okay, max height I am getting here is 2, and in this height I am subtracting 1. Definitely we have to subtract 1 in it, because this is nothing but number of nodes before that. Okay, so here what I am getting, 2 plus 1, 3 only. I am getting 3 only, right? So how does this working? So it is working like this. I am removing this 3. Okay, I don't want to mess this diagram, so that is why I am explaining here. So this is nothing but my level 0, level 1, level 2 and level 3. Okay, so here at level 2 I remove this. Okay, so let's suppose there are some more something like this. Okay, so bigger. Okay, some bigger value, but if I remove this, then definitely this is of no use, right? So then after that I have to check the max height of these nodes. Okay, at this level, so max height I am getting here, and I know that I am removing 3 from here. Okay, so in a single operation, in of one time, I get to know that at level 2 I am removing for something, at level 2 I am removing something, and in the single operation I will get to know about the max height at this particular level. So max height I get at this particular level is 2 minus 1. Okay, so here 2 until here I get, okay, 2, and below that the height I get as 2 minus 1, 1. Okay, I will directly get my result. Okay, in O1 time complexity. Okay, so here few more things that we need to take care. Okay, we know about the level and height and how this is functioning. This is functioning like this only, level plus height minus 1. Okay, in this way, and we know about the levels array and we know about the heights. Okay, now one more thing. Okay, so here if I remove this, let's say 3, and we have all this stuff, then this 3 will have the max height. Okay, what I'm saying, if for this 3 there are some nodes like this, and like this, so at this particular level this 3 has max height. Okay, let's say this 3 has max height at this particular level. Okay, then in that case we have to consider the second highest, right? So here there is one problem now. So if you are removing this 3, if you are removing this node 3, okay, then you are checking for the nodes 1, 2 and 7 which are at the same level, but you are iterating over them again and again, 1, 2 and 7, and then you are checking the max one. But isn't it good if I just store the max height and second max height, okay, in one separate array in a single go, so that all these functions will work in of one time complexity, right? Then it will be beneficial, okay, instead of propagating over all the nodes at that particular level again and again. Okay, I have moved this node 3. Now I'm checking 1, 2 and 7 out of these 3 which is max, pick that. But instead of that, if I directly store level wise max and second max height, then it will be beneficial more for me, right? It will directly give me the answer in open time complexity. Okay, so here what I'm going to do, I'm going to create a one more array, okay, two more arrays, let's say. And this is one array and this is one array. Okay, so here in the topmost, okay, so here how many levels we have? Total 0 1 2 3 levels we have. Okay, so 0 1 second, 0 1 2 and 3. Okay, and here 0 1 2 and 3. Okay, so this is nothing but my level max height, level max height, LMH, level max height, and this is nothing but my level second max height. Okay, so at level 0 max height and the second max height same. Okay, so I'm feeling 4 4. At level 1 max height is 3 and second max height is 2. Okay, at this level max height is uh okay, so here one more thing. Okay, so here instead of this I'm storing this. Okay, so okay, let's say 4 and 3. Okay, and here at level 2 max height is 2 and second max height is 1. Okay, at all the same position we are getting 1 1, so write 1 only. Okay, no issues. At level 3 max height is 1 and here 1. Okay, so now if I remove this 3, okay, and 3 is nothing at which level, this is at level 2. Okay, so at level 2, okay, at level 2, at level 2 we have removed 3. Okay, so now at level 2 you see max height is 2. Okay, max height is 2. Okay, and we are going to use this max height only by why we are going to use this max height only, because we have removed this one and this one is not the max height at this particular level. Okay, so now how we are going to get to know that this 2 is my max height or not? So simple thing na, I am just going to check the height of this node 3, and if the height of this node 3 is matching with the max height of this level 2, okay, then in that case we don't have to use this, then we have to use second max. But if the height of node 3 is not matching with the height which is max at this particular level, then use that. Okay, so simple. In over one time complexity I'm going to use all the same things. Okay, so I'm going to this one tree code. Okay, calculate the height of tree code. In that particular code I'm going to do all these things in a single go. Okay, code is going to be very simple for this one, but this is just a few things that we need to know before solving the problem. Okay, so one thing, we need to store the levels, we need to store the heights, we store the level wise max height, we need to store the level wise second max height. Okay, so that's it. Okay, and by using them we can solve this problem uh, in a single go. Okay, for this query single go, do that. For this query single go, use this formula, get the output. For this query single go, get this output. So this query single go, get this output. Only one time operation we need to do this, and we will do all this stuff while calculating the height of the tree. Okay, so now how I'm going to solve this problem? Okay, that's the main question. Okay, how I'm going to write the code for this one? Okay, so here first I'm going to write the code how I'm going to get the height. Okay, so let's do one thing, I will explain the code here while writing it. Okay, without wasting any time, because if I explain the code here then I have to write it again here. Okay, then it will give you guys confusion and video will go a little bit lengthy. Okay, so let's do one thing. Okay, so now here first thing we need few things. We need array. We need to create one array for level. We need to create one array for height. We need to create one array for level max height. We need to create one array for level second max height. Okay, so here what I'm going to do, first see here one thing, how many number of nodes I have. 10 raised to power 5. Okay, so here let's suppose all the nodes are like this: 1 2 3 4. Okay, so if all the nodes are like this, then number of nodes will become my the height of the tree. Okay, if all the nodes are like this, okay, in the worst case scenario it may be the case, right? So here the array that I'm going to create, okay, for level height, level max height, second max height, I'm going to consider this only. Okay, so here what I'm going to write, private int level, okay, new int, and here I'm going to give the size as, okay, so 10 raised to power 5 size was given. Okay, number of nodes we have, so 1 2 3 4, and in this I'm just going to add 1. Okay, 1 2, like this we have nodes, right? So that's why I'm going to write it like this. Okay, so here 1 2 3 4 5. Okay, that's cool. Okay, now height. Okay, so this is for level. Now copy this same thing, paste it here, paste it here. Okay, and here instead of level I'm going to use height, and here instead of level I'm going to use level max height. Okay, max height. Okay, and here I'm just going to use level second max height, level second max height. Okay, okay, spelling is correct, right? G-I-G-H-T. Okay, I'm using correct spelling. Okay, okay, so now we have to write a method to find the height of each node and populate the max heights at each level. Okay, so what I'm going to do that. Okay, so from root I need to get start and calculate the heights and all that stuff. Okay, I have to make all this stuff. Okay, from the root I have to start. Okay, so here I'm going to write the method. Okay, so here let me add the comment, method to find the height of each node, okay, and populate the max heights, and populate the max heights at each level. Okay, this is what we need to do, right? Okay, so here private int find height. Okay, and here inside this I'm just going to write tree node, and here from root I'm starting, and here int l. L is nothing but my level, so initially my level value is 0 only. Okay, so I'm starting from 0 only, right? And root and 0. So here if my root is equal to null, if my root becomes null, then in that case what we need to do, we have to return 0. Okay, so here while propagating, if I reach the end of this one, okay, like this, then if this becomes my root which is null, then I'm returning 0. Okay, so this is the case. Okay, then here, okay, so here initially I'm at this position. Okay, at this position. Okay, root and level 0. So this value 5 I have to write 0 here. Okay, I have to write 0 here. How I'm going to write that? So here I'm writing level, okay, which is my array, and this level at which index is going to be this 5. This 5 is nothing but root dot value. Okay, so here I'm passing root dot val. Okay, so for this what is going to be my level? So my level initially this L, okay, it is 0, so here I'm writing L. Okay, clear? This is done. Now height, how I'm going to fill the height? Height where, which index? Index is nothing but this root dot value. Okay, so here root dot value height I'm filling, Okay, so here how we are going to get the height? Height is nothing but max of left and right. Okay, and this is how we calculate the height, right? So here what I'm going to write here, height is nothing but math dot max. Okay, and after that math dot max, inside this I'm just going to call this method find height. Okay, copy this, paste it here, find height. And in this find height I have to move to the left side and I have to move to the right side. Okay, so if I'm moving to the left side, so here I'm writing root dot left and my level will be incremented. Okay, if I'm moving to the left side. Okay, so here I'm going to pass for the next time my level as level plus 1. Okay, this is one thing, right? Same way, now just copy this complete part. Okay, and paste it here. Same way we have to move to the right side as well, right? From left and right we have to get the max, right? So here find height root dot right l plus 1. Okay, this is what, okay, this is done. And now here what we were doing, we were doing like this, we are finding height like this, max of l comma r, and then we are adding one more time, right? Here, so from here I'm getting 0, from here I'm getting 0, max of l and r we got it here. Okay, and after that we are adding 1. Okay, so this way we are getting the height. So here once this is done, then after that I'm going to add 1 to it. Okay, so here this way, right? So find height, I am passing two values, one is root, next time root, and the level I am incrementing. But to calculate the height we have to add 1 as well, right? This way, like this. Okay, so this is done. Now this is done. So here I know how I'm feeling level, how I'm feeling height. Okay, I know about this thing. One second, I know about this thing, I know about this thing. Okay, now let's fill this level max height and level second max height. Okay, let's fill these two things. Okay, so here understand it carefully. If my level max height, okay, so here let me just copy this. Okay, if my level max height, okay, level, okay, so here what I'm writing 0 1 2 3, these are nothing but levels. 0 1 2 3, these are nothing but levels. Okay, levels these are. Okay, so here if level max height at this particular level, okay, if it is less than, okay, if this is less than the height of that particular value, root dot value. Okay, if this is less than, then we have to update. Okay, if this is the case, okay, then I have to update my level max height as well and second max height as well. Okay, so if my level max height is less than this one, so definitely this is going to, this level max height is going to become this height of root dot value. Okay, and this is one thing. And one more thing, my level second max height is also going to get updated. Okay, so level second max height of at this particular level, this is going to become equal to this previous one. Okay, easy, right? So I am, if my level max height is less than this one, so my second max height will become this one, and this will become equal to height of root dot val. Okay, easy. So this is how we do that, right? It's very common thing, right? And in the else part, okay, in the else part, if my level max height is not less than or equal to this, okay, is not less than this, okay, then we have to just update my second max height. And when we have to update the second max height, when my level second max height, okay, if this height, level second max height at that this particular level, okay, if it is less than height of my root dot value, okay, root dot val. Okay, this is done. And here just update this now, so just copy this complete. Okay, paste it here, and then I have to update my second max height only. Okay, this is done. Okay, and then we have to return. Okay, once this is done, from here we have to just return the height of root dot value. Okay, height of root dot where. So this is how we are going to calculate the, we are going to get all these things, all these stuffs. Now the code is very easy. Okay, now we are left with just common things. Okay, but this is the beauty of this. In this single thing we are in this single thing, right? One second. In this single thing we are calculating level height, level max height, level second max height, all the things we are getting, okay, in the single method. Okay, so now once this is done, now let's move to the our main. Okay, so our main method, which is nothing but this public int tree queries. Okay, so here let's do one thing here. Let me just do one thing here. Let's copy this, okay, this part until here. Okay, this I'm copying it, I'm moving it outside class edition. Okay, until here. Let me just format it. Okay, so this is done. Okay, so here in this I have written the method here. Now in this main method, what we need to do, okay, let's do that. Okay, this is done. Now in this first, let's, in this main method I'm just going to call this find height. Okay, so here find height, and here initially I'm passing root and my level as 0. Okay, this is what we need to pass, and then this is going to calculate the height at each for each node, okay, for me, and it is going to give me the level height, level max height, level second max height, everything. Okay, it is going to give me. Okay, now here let's create one result array in which we have to return the answer, and we know the size. Okay, initially I told you that the size is going to be equal to my queries dot length only. Okay, this is done. Then just iterate over all the queries one by one for int I is equal to 0. Okay, and guys, please don't forget to add the comments in this video, give your feedbacks, because your comments motivate us. Okay, don't forget to like this video, and please subscribe my YouTube channel and share this with your friends and all. Okay, and don't forget to add the comments. Okay, it gives us motivation to give more efforts in the next videos, right? Okay, so now here let's first take that particular node. Okay, so here int that node is equal to queries of I, and here after that level int L. Okay, here we have to get the level of node. Just pass this, we will get the level, and here we will get that particular node. Okay, so now it's very easy now. So here we have to just calculate the result for this particular node. Okay, so here int temp result. Okay, let's create one variable temp result. So here how we get calculating the result? Simple, n plus h minus 1. So level. Okay, in this level now I want to remove that particular subtree. Okay, so here I am going to check one thing. Okay, if my level max height, if my level max height at this particular level, okay, at this particular level, okay, L, if this is equal to height the height of that particular node, okay, then in that case we have to use the level second max height. Okay, so here just let me copy this, we have to use this. Okay, if it is equal to max height, level second max height, and here inside this I am going to pass L, otherwise just use level max height. Okay, so this is what the common thing. Okay, in of one time I'm going to get this temporary result whatever I have. Okay, this is done, and here we have to subtract 1 from it. Okay, we have to subtract 1 from it because we were calculating the number of nodes, right? So that's the reason. Okay, so this is done. Okay, now I have to just update my result of I. Okay, so here result of I is equal to my temp result. Okay, this is done, and in the end just return result. That's it, we are done. Okay, so now let's run it. So all the test cases has been accepted. Wonderful, right? in a single attempt we are able to pass all the test cases. Okay, now let's submit it. So see, our solution is accepted, right? Now time complexity. So time complexity for this problem is going to be of n only. And the reason is very simple. See, we are calling this find height, and in this find height we are iterating over all the nodes. Okay, we are just moving over all the nodes in just one time, right? So that is why I am going to say that the time complexity for this one is going to be of n. Okay, so we are iterating over all the nodes one by one only. Okay, and in a single go I'm updating my level height, level max height, level second max height. Okay, and here we are iterating over the queries that we have. So for this part you can say the time complexity is going to be of m. Okay, of m for this one. Okay, so but this O of m definitely is going to very small than this O of n. Okay, this is very large. So that is why overall time compression that I'm going to say is going to be O of n only. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.